Last year I did the wrong axis. I'm going to do the right axis this year. Okay, so our goal here is to integrate with respect to y versus respect to x. Okay, so we've got one where we did an example of x. Now we're going to do an example of y, and then we'll do a shift. Okay, those are basically the three things we had to cover today. So just to find the volume of the solid generated about these graphs, okay, about the y-axis. So the y-axis is important that we're revolving around that. So I'm revolving this way this time, okay? We're supposed to sketch it, draw a representative rectangle. So to do the sketch, it's better if it's y equals something. We know we are more familiar with trying to sketch that. If it's already an x equals, you can always go back and use the t-chart if you don't have your calculator, okay, if it's a non-calculator problem. So I'm going to try to graph this. What is this a picture of? It's a parabola. Where's the parabola shifted? One up. Okay, so we're going to do this. We are likely going to, whatchamacallit, we're going to see it come this direction, right? And it's going to go up like this. If it's not perfect, it's okay. All right, we've also got that y equals 0. That's the axis. Okay. Let's see. Yes, y equals 0 is the axis. I don't think that's y equals 0. No, that's x equals 0. Y equals 0 would be here, wouldn't it? All right. And then, yeah, I was in the wrong spot. And then we have between x, wrong color, between x equals 0, which would be here, and x equals 1, which should be here. So hopefully you're seeing the region is this region in here. That's what we have to revolve. And our rectangle, let me put it in black, would be going this direction. So we're taking that little rectangle and we're revolving it around this. And remember with the disc, your region is touching the axis of revolution. Okay, whereas we'll deal with the washers on Monday, but the washer, it's not. Okay, but that was kind of a thing we learned last year. Okay, so if I am going to be in terms of y, this one's going to be weird, isn't it? Two integral case. Okay, so we have a little bit of a catch on this one. Do you see how from up to this point, there's this goes across from, it's going from the purple line to the pink line, whereas here it's going from the purple line to the green line. So we're going to have to set up two different integrals, okay, to do this one. So let's see what I can do with the space. I guess we're going to go here. So anytime I do a revolution, how is it going to start? It's always going to start pi. Okay, so we're going to go volume equals pi. Okay. And we're actually going to end up doing two separate integrations. So I'm going to do that twice. Okay. What is my first integration going to be to and from? And remember, we're looking at the y values. So I'm going from y equals what to y equals what? 0 to 1. Good. And then just because we're able to pick it up off our graph, we're going from 1 to where? 1 to 2. Good. All right, this is going to be our right minus left situation, okay? If it helps you to write it on there so you know what it is, that's x equals 1. This one is x equals 0. So it looks like my first integration is just going to be 1 minus 0. We'll go back to purple like that, dx. Oh, not dx. We're in dy, aren't we? dy. All right. My next one's a little bit trickier. Remember, I have to be in y's. Oh, and I'm supposed to square it too. I missed the squared. I have to be in y's. So that means that this thing here has to be solved for y, okay? Or sorry, for x. So I'm going to do that work off to the side here. So I'm going to move the 1 over, equals x squared. And then I have to take the square root of both sides. Technically, it's a plus minus square root. In our case, because of the bounds that we have, we really only have the positive case of that square root. So this thing is going to be the square root of y minus 1. Okay, so let's put that in our function over here. I'm going to write tiny, if that's possible. All right, so my right is 1 again. I'm going to subtract, and I'm going to use some parentheses. Oh, I don't need parentheses. It's got a root over the top. Square root of y minus 1. Okay. And I lost a plus sign. This should be a plus sign in between there. All right, we're going to see what we can do with the integration. Let's see how far we get with it here. It's going to be a little bit ugly in that second part. So this first one is really just going to be pi, the integral from 0 to 1 of 1 squared would be 1 dy. So let's go through, oh boy, let's go through with that integration there, okay? And then we'll see if we can do the other one. Get it to connect. I don't know why it does that. We must have internet blips or something and it kills it. Come back, let me touch that. There it goes. Okay, so when I integrate 1 dy, what do I end up with? Just y. Good. So we've got pi y from 0 to 1. When I plug in the 1, I'm just going to get pi. When I plug in the 0, what would I get? 0. So do I really need to even write that down? No. Okay, so I'm done with the first part of it. Okay, and if I need more of them, I just keep writing a pi in front. Okay, so now it's going to be plus something. All right, before I try to integrate this mess on the other side, I would probably try to FOIL that out because I have to square that thing. And remember, I can't just distribute the square. So I'm going to do some scratch work here. So find some space to do some scratch work somewhere. All right, so 1 times 1 is just what? 1. We're going to have 1 times this thing, and we're going to have that twice. So wouldn't that give me negative 2 squared of y minus 1? And then a radical times itself is just the stuff underneath, but we're going to have that minus. Oh, no, negative times a negative is going to be positive, so it's just going to be that. I really don't actually need these parentheses here. What's going to happen? Can I simplify that at all? Yeah, the ones that get to cancel. So what I really have is y minus 2 squared of y minus 1. You don't necessarily have to rewrite it there. So I'm going to put that in over here. So y minus 2 squared of y minus 1 dy. Okay, so let's integrate the first piece. I'm going to have pi, and I'm going to use a parentheses here. So I make sure that everything's distributed correctly. When I have y, what do I get when I integrate y? Perfect. Okay. Technically, I really should split it into 2 integrals. I'm being really lazy right now. Okay. What am I going to need to integrate the square root of y minus 1? Yes, we'd have to use a u substitution. Okay, but let's think about that for a second. My u would just be y minus 1. So what's du equal to? 1 dy. Do I really need to do the u substitution, or can we just shortcut? Yeah, let's just shortcut, right? So when we're thinking about this, it's really to the 1/2 power. We know we have to add 1. So we get y minus 1 to the 3/2. And then what would I put in front? 2/3. Okay, so we're going to now take that and transfer that back over here. Sometimes it helps to just think about it on the side for a minute. So 2 times 2/3 y minus 1 to the 2/3 power from 1 to 2. I don't think we're going to simplify all the way today. It is Friday, right? We'll get it plugged in. What's wrong, Fallon? Yes, it would. Thank you. I have a typo. A righto. There we go. Is that better? Okay. I think I got a parentheses there. Okay, so we're going to plug in the 2. We're going to plug in the 1. And probably that's going to be it. We're probably not going to go simplify all the way. All right, so I've got a pi hanging out. Let's see. 2 squared is 4. Divided by 2 is 2. Everybody okay with that train of thought? So 2 squared is 4. Divided by 2 is 2. This thing here is going to just be 4/3. So minus 4/3. 2 minus 1 is what? 1 to any power is still going to be what? So all I get off that back piece is 4/3. I did a lot in my head. Okay. All right. Then we're going to go minus. What always comes after a minus sign? What do we have to write? Good. Parentheses. All right. We're going to put in a 1. So we're going to put in 1/2. Let's think about what happens with this back piece. This is a multiplication sign right here. What's 1 minus 1? 0. So it's going to make this 0 and this 0. So do I really need anything besides the 1/2? No. All right, let's stop there. It's a number, right? We're good. In fact, if we were really lazy, we would have just plugged in the 2 and the 1 the way it looks and not done any of the arithmetic in our heads. I know that's like my favorite thing to grade. Not really. But I would grade it for you guys. Okay. We got just enough time to finish up the last one with the shift. Okay? All right. So, here we go. Really quickly, read the essential question and the I can statement to yourself. How many miles do you think the band's walked at this point? All right, Michaela, can you read us the essential question?
How do you calculate volumes of evolution using definite intervals and this method with a shifted?
Perfect. And Matthew, can you read us the I can statement?
I can calculate volume of evolution using definite intervals, and this method was a shifted axis.
Perfect. Okay. So we said at the beginning of the lesson that the axis doesn't have to stay on the x-axis. We already saw it go on the y-axis, right? So we don't have to even keep it there. We can move it other places, okay? And more likely than not, on the AP test, it's usually a shifted axis, okay? For you guys this year, your volume question is typically, or volume like this, is typically in the multiple choice, because we do volume parametrically, and with polar is typically what goes in your free response, which we haven't gotten to yet. That's next semester, okay? So, but it's good that we can see this in the multiple choice, okay? All right, so to yourself really quickly, read that, okay? Okay. What should my f of x look like? What is that a picture of? Yep. Where's the intercept or the vertex going to be at? 2. Good. So we're going to go here. We're upside down. It's going to look like this. And again, we aren't expecting perfection here. This one's pretty simple. If we had to get the actual intersection points without looking at the graph, remember we set the two equations equal to each other, just like we did. We're kind of being lazy today and reading it off the graph. Okay. So this was this one. G of x equals 1 is going to be a horizontal line right here. So again, when we're sketching by hand, we should probably verify that we know our intersection points are -1 and 1. It doesn't hurt to off to the side really quickly go set those two things equal and solve it, because look, that's not that hard of a solve. I'm going to move the 2 to the other side. So -1 divide by the negative square root. So x equals plus or minus 1. So we verified that we know that this intersection is at -1 and that intersection is at 1. Okay. Just as a reminder, that happens. Okay. You might not get it right away, or you might not, if you're just sketching without a graph patch, right, and you're kind of doing a sloppy sketch, you want to always verify that. Okay. All right. It says, what are we revolving about this time? Yeah, y equals 1, so we're revolving around here. This here is the region we are revolving. So our region is still touching that axis of revolution. Okay. But this time we have kind of an inside function and an outside function. All right. Nope, that's more tomorrow. We're going to do our top minus our bottom, just like we did before. Okay. So this is the top, and the green one would be the bottom. So not much different than when we envisioned it being 0, right? So if you kind of do that -0 and it's always top minus bottom, you should kind of just keep that in your head, and it should work every time. Okay. All right, let's set up volume. So volume equals, when I do volume, what do I have to put up front? Pi every single time. What are the bounds that we calculated? Good. All right, we're in the dx direction, thank goodness. What is going to go in for my top? Good. And what's going to go in for my bottom? 1. Remember, I have to subtract those things. All right, we're going to do a little simplifying. So pi from -1 to 1. What's 2 minus 1? Right? Squared dx. What do I have to do with that integrand in there before I can integrate? Can I do a u sub? Does that work this time? U would have to be that, which means du would have to be this. So can I use that? No. Okay, so what am I going to have to do? What algebra do I need to do? Am I allowed to distribute? What does the squared mean to do? It means to multiply. It means we're going to write it twice, right? So you need to do that. Okay? So you're going to FOIL or distribute or multiply, whatever you want to call it. Okay? And then you're going to integrate. All right, you've got enough time. Try it on your own. See if you can get it done. Always good practice to do the integration. Okay, let's see where we're at. We have some options right here. Let me explain our options from here. Are we all okay with the integration? Did we do that part right? X minus 2/3 x cubed over 3 plus x to the 5th over 5. We're all good there. All right, sometimes it's the plugging in part. And again, we could technically be done with what I just showed there, okay? But we do have options with that pi out front. We're still going to need the minus parentheses in some way, shape, or form for the part where I plugged in the -1, okay? But I could do this and add big parentheses. That might be easier to see if we were going to try to simplify all the way rather than having that pi hanging out in there. Okay. All right. So in this back piece, in the first place, it was just whatever the function was or the term was with the correct sign. In this one here, remember, I plugged in a -1 and I plug a negative into this. The cubed remains negative, so negative times negative turned out to be positive. And then the 5th power is going to be negative. Okay. If I was going to simplify all the way, what would I need to do next? Yeah, we got to distribute the negative in. So that would make this positive, negative, positive when I distribute that in. All right, and I'm going to use my little trick that I used before. Okay, I've done this a couple times with you guys. We're going to have 1 plus 1 is 2. Negative 2/3 and negative 2/3 is negative 4/3. And 1/5 and 1/5 would be 2/5. Which is better than trying to get to them all to a common denominator right away. Because sometimes we have some things reduced. Didn't happen so nicely this time, but it happens sometimes. All right, so I'm going to go to a common denominator of 15. All right, so that would be 30. Got to multiply by 5, so 20. Got to multiply by 3, so 6. 16/5, is that right? Make sure I'm doing my arithmetic right. Sorry, 16/15 pi. See if I did it the same way last year. Yep, got the same thing I got last year. Okay, so not so bad. What I put out there for you guys to get some practice, because our opportunities to quiz and requiz are very slim, right, at this point. I think my plan is for us to be quizzing on this. I want to say it was next Thursday-ish. Maybe it's Friday. But then we've got to really quickly turn around an opportunity to requiz for you by finals day. Okay. Make sure you're practicing a little bit. You don't have. I think I put 5 whole problems out there. Okay. I want to say that they're on the calculator though, because I use Delta Math. There's also some in AP Classroom, so those might have some non-calculator in there for you. So pick what you want to, what you feel you need to do to get comfortable with it and practice a little bit. Okay. All right. That's all I got. So you can spend the rest of the period working on assignments.